Hi and welcome back. In this video, we're going to talk about vertex form of a quadratic function. So our motivation here is that we would like a way to easily identify the vertex of a quadratic function just by looking at its formula. So thus far, we've talked about standard form of a quadratic function, which looks like f of x equals ax squared plus bx plus c. However, this form doesn't tell us anything about the actual vertex of the parabola or of the quadratic function. So we'd like to be able to rewrite this in a different form, a form we're going to call vertex form, that allows us to easily identify the vertex. So what I'm going to do is give you the formula first, then we'll talk about where it comes from and do some examples. So we say a quadratic function that has the vertex h, k, so that's the point hk as the vertex. This function can be written in vertex form as the following. So we have f of x equals a times the quantity x minus h squared, all plus k. So a, x minus h squared, plus k. Here, a is still the leading coefficient, so this is the same leading coefficient as in standard form, but now we have the vertex easily visible. So the vertex is this h and this k in the formula. As a comment, you'll see that it's minus h. We still use the positive h value as the vertex point, but it looks like a minus h in the formula. So personally, I kind of feel like this form looks like it comes from nowhere unless we talk a little bit about how transformations help us get here. So the way I make sense of this formula is by thinking of transformations. You might just be happy accepting it as it is, but I'm going to walk through the transformations about how we get here in case that makes it clearer to you. So specifically, we're going to start with our most basic quadratic function, x squared, and move it around with transformations. So starting with x squared, we're going to do a horizontal shift by h. So we'll do x minus h, and that whole quantity becomes squared. So taking the input, shifting it by h horizontally. All right, now we're going to do a vertical scaling of the parabola by a factor of a. So we'll take what we have thus far and multiply the entirety of it by a, since we're multiplying the outputs by a to do that vertical scaling. So here I have a times x minus h quantity squared. Lastly, we're going to do a vertical shift by k. So we'll do a plus k at the end of this in order to shift it vertically, either up or down by k. So this looks like a times the quantity x minus h squared plus k. So what this effectively does is it starts with our vertex that's at 0, 0, and it's going to move it to the location of hk. Using Desmos, we can explore what this looks like. So I've graphed it here so that we can try some different values for a, h, and k. So first, as we input an h value, the function is shifting horizontally. So I'm going to use h as 3 for our demonstration here. So if we have x minus 3, this is a shift to the right by 3. Now let's use an a value to do some sort of vertical scaling. You can see if a is positive, it's just vertically stretching or compressing it. But then as we have a negative a value, we are also doing a reflection over the horizontal axis. So I'm going to do an a equals negative 2, just for now, for us to see this. So our parabola is reflecting over the horizontal axis and doing a vertical stretch by a factor of 2. Then lastly, when we incorporate k is moving the parabola up or down. So here I'm going to use a k value of negative 4, which moves the graph down 4 units. Okay, so we've started with our vertex at 0, 0, and now by doing an h value of 3 and a k value of negative 4, we have shifted the vertex to 3, negative 4. So I'll have this available so you can try some different values for h, a, and k, but this is just a little bit of why this formula works the way it does, is we're taking our initial parabola x squared and we're shifting it around to move the vertex to this new location, hk. Alright, so now I want to go through an example where we look at a quadratic function written in vertex form and identify some information about it. So first, let's start with the function g of x equals negative x minus 2 quantity squared plus 3. and I want us to find some things about this function. So let's identify the leading coefficient, the vertex, the vertical intercept, and then sketch a graph. So this function is written in vertex form, so we have a x minus h quantity squared plus k. So this should help us when we're trying to identify each of these parts. First, our leading coefficient is the a value that's in the front of the function. So for us, that's a equals -1. It's written here as just a negative, but there's really a -1, so our a value is -1. And what I want to notice here is that because our leading coefficient is negative, this means the graph of our parabola is going to open downward. So I comment on this here so that we can keep it in mind when we do the sketching of the graph. All right, next we need to identify the vertex. That's our hk value. So if I compare vertex form to what I have, I'm seeing that the h is this 2 and the k is the 3. So my vertex is going to be 2, 3. As a comment, you'll see that vertex form is x minus h. So we compare this to x minus 2, and this tells us that the h value is +2. So we're not doing -2, we're doing +2, so that it lines up with our formula. Okay, then lastly, one of the things we're often asked to do when we're doing these new functions is to find the intercepts. So I want us to find the vertical intercept. We're going to use the same process we did with linear functions. So the vertical intercept occurs where the x value is 0. So we're on the y-axis, meaning our x value is 0. So we're going to substitute in 0 for x and simplify. So I'm going to put 0 in for x, so I'm looking at g of 0. Then I replace x with 0, so I have -0 minus 2 quantity squared plus 3. So the 0 minus 2 simplifies to -2, so I have -2 squared plus 3. -2 squared is a +4, since a negative times a negative is a positive. This is then -4 plus 3, which is just -1. So when I input 0, I'm getting an output of -1, and this tells me my vertical intercept is the point 0, -1. Okay, so I had us find this point because it's often very helpful for when we're trying to graph. So when we move to graph, we're going to use this point to help us out. So I have some axes here. Our vertex is the point 2, 3. Our vertical intercept is the point 0, -1. And we're going to remember that the parabola is opening downward. So I'll graph the vertex here and the vertical intercept. Then if you're using some sort of online homework tool, this is actually enough in order to draw the graph. But if you're doing this by hand, you might want some more points to help you out. So I like to use the symmetry of the parabola. So if I have a point at 0, -1, I have to have a point on the right-hand side of the vertex that's in the similar spot. So for us, that's 4, -1. If just looking at this and finding the symmetry isn't working for you, you can always just plot another point by substituting in the value. So maybe you substitute in 5 for x, you go back to the formula, you substitute in 5, and you find the y value. That's totally fine. So you can always substitute in more points to graph them. But I'm going to leave it at this and draw a sketch of my parabola here. So there we go. This is what the graph would look like based on our equation written in vertex form. Alright, so that is an introduction to vertex form of quadratic functions. That's it for this one. Thanks so much for watching, and I will talk to you in the next one.